Algorithms power the very core of top applications today, driving search engines, social media, and AI large language models. Perhaps no one knows this better than Professor Robert Tarjan, the 1986 Turing Award winner for the design and analysis of algorithms and data structures. He's in Beijing for the 2026 International Congress of Basic Science. In our one-on-one conversation, he talked about how quite simple AI algorithm can be, but very capable of doing large-scale gathering of data and compressing it into something humans can do. So beyond today's algorithm, he says smart AI needs the intrinsic human curiosity to explore and investigate the world. Take a look. What is your observation of today, the opening of the ICBS? How scientists do you think are celebrating this moment?
I think everybody is extremely enthusiastic, and it's a wonderful meeting, and it's nice to see that the government and the universities are supporting basic research in science. Basic is important. I think curiosity-driven research is extremely important. Everybody wants applications, which is the natural thing to ask for, but you don't get to applications without understanding the way nature works, the fundamental.
Sir, you've been interacting with scientists coming from all over the world, of course, including those that are in China. You visited Tsinghua University, for example. How do you see China's approach in building this ecosystem for nurturing talents?
It's very impressive, I have to say. Well, this conference is an example, right? There's a lot of money that the government is pouring into basic research, which is extremely important. And at least everyone is saying we believe in open research, international sharing, which I think is very important because that's the way you make progress. So I think the current approach of the Chinese is very impressive. I love to do research with people all over the world. You get different points of view, you get different approaches to problems. And I'm a believer in open scientific research, and the more we can open up things and share ideas, the more progress we're going to make.
How do you see the kinds of talents that needs to be nurtured? Because we know AI eventually going to replace a lot of the current work that people are doing. And we also know AI is likely to transform to a certain extent for science.
So I'll make a couple of comments. First of all, you know, back in the 1950s, when I was a small child, there was this idea that technology was going to give everyone lots of leisure time. But somehow, all these technologies have only forced people to work more and more and more. But we have the resources to allow people to have more free time, actually. So maybe we need to redesign things a little bit to share all this wealth that is getting generated by the technologies to not require people to work full-time in order to support themselves. Maybe we should return to this ideal where you don't spend your entire life doing nothing, but you don't have to work so hard. Then people have a little more time to work on the things that they love. That's what I've always had the privilege to be able to do, work on what I love. It's so important, right? But we don't need everybody working full-time constantly because these systems can help us. So let's figure out a way finally to, this is very idealistic, but wouldn't it be nice if we can share with the bounty that's coming from all these systems with everyone and give people some freedom and some more free time. So what are humans going to do? Use these systems to do the tedious tasks, right? What does that leave for humans? The interesting stuff.
Yes. Why not?
Yes. So let's find a way to use these tools to our advantage and free up our time to do the interesting.
I was thinking about this. If we are as smart as already being demonstrated in coming up with the latest technology of AI, can't we come up with some kinds of algorithm that would help us to understand better how to share the wealth?
There is a question to
There's a
ask your
question.
large language model, but it's a very important question, maybe the most important question.
Decades ago, when you were winning the Turing Award, nobody knows today algorithm, which your research certainly helped greatly, has become such an important component of artificial intelligence and have an impact on everybody's life.
Well, my training was in mathematics, actually, but when I was very young, I had an opportunity to program very basic computers. And in fact, the first computer I programmed was called the Bendix G15. It was a refrigerator-sized device with a paper tape reader, and you could program it to flash the lights and so on.
Really?
And I was programming in assembly language, which is very painful. But the second machine I had an opportunity to program on had Fortran as the programming language. And it's like mathematics. You can actually express algorithms in a mathematical form that both a human and a machine can understand. And it was a revelation to me. So I loved mathematics from an early age, but doing computer science, I could make the mathematics concrete and make it actually do things for me. So I ended up in computer science, but of a theoretical sort.
Right. And what do you make of the nature of algorithm these days? There are a lot of questions related to it.
Well, an algorithm is just a recipe, like a cooking recipe. You provide the ingredients and you specify how to put them together. But the word algorithm has become dirty because, first of all, it's a dirty word, which I find personally alarming, shall we say, because what happened was these systems of various sorts collect lots of data and then use the data to drive user interactions. And there are underlying algorithms that do this, but they're not necessarily, let's say, helpful or honest. And the algorithms behind artificial intelligence, large language models, the algorithms are very simple. It's just large-scale matrix multiplication. What is going on with these things is it's the massive data that is really driving the outputs. And how we get from the massive data to the outputs through these matrix multiplication, very simplistic computations, is something that nobody understands. And it's kind of astonishing what these systems can do on the one hand, but it's also astonishing the kinds of simplistic mistakes they make on the other hand. So these are not the kinds of algorithms that I design. Try to make them simple, understandable, but usable in general situations. It's kind of the underlying plumbing that runs in all kinds of computer systems.
So the natural question for me to follow up is the current complex, unknown world of algorithm. Why have we stepped into the current reality?
Moore's law is the main reason.
Yeah.
The idea that underlies these large language models, these neural net systems, layers of basic elements, one could call them artificial neurons, they're tied together. It's a very simplistic structure, but then you run large amounts of data through them and repeatedly correct and correct and correct, and you get some kind of incredibly complicated system that produces some outputs in response to the giant input, but you have no idea what's going on the inside. So this idea has been around for, I don't know, 40 years at least, but it was only with the advent of both the internet and huge computational abilities that people were able to train these systems on essentially everything that's on the internet and produce unexpected, mysterious, complicated, but very useful.
How to unveil the mystery? Do you think you have some ideas already?
I'm not so confident in myself to believe I understand.
What are some of the directions you think?
Well, I think that these systems are different from the way human beings reason.
Right.
And I think they're incomplete in some sense. There are pieces missing. The true believers think we will get to artificial general intelligence
Whatever that
by
means.
scaling these systems up, whatever this means. Yes, I think there's some missing secret sauce that we don't understand. Maybe it's motivation. The thing about human beings, for example, even as a baby is curious, a baby is exploring the world, a baby is motivated to investigate.
Yeah.
These systems are not motivated in the same way. Maybe we have to build in some kind of motivation, some kind of curiosity-seeking mechanism. I also think that these systems don't have any structure to them, and that we know that the human brain has many specialized organs to do certain kinds of computations, and human beings have an incredible ability to create abstractions, layers of abstraction. There's a mental model going on, which is something other than coefficients in some giant matrix multiplication. So I think there are missing pieces to get to something resembling artificial general intelligence.
They sound like crucial missing pieces.
I think so, but we shall see. I mean, these systems are getting so good so fast. We'll see maybe over the next decade just how far these systems can get.
Related to this, do the artificial intelligence technologies these days really have so-called intelligence, or they are just very good at computation?
They are not doing what I would regard as intelligent, but, and they're very good at computation. They're very good at taking lots of knowledge,
Right.
essentially everything that's on the internet, and synthesizing it and comparing it. Are they drawing conclusions? I don't know, but they're very capable of doing large-scale gathering of data and compressing it into something that you as a human being can use. It's an incredible tool, very powerful tool. It's changing my field, mathematics programming, drastically, because the thing about mathematics and computer programming, unlike a lot of science, the answer is black or white. A theorem is true or it's false.
Yeah.
And it's something that you can verify. If a computer comes up with a proof or a program to do something, you can verify whether it's actually correct or not. So you can test and evaluate. And that's the thing about science. You want to be able to do reproducible experiments. You want to be able to, you come up with a hypothesis, and then you need to be able to test whether it's true or false, a conjecture. But we can verify the results provided they're talking about something concrete, a computer program, a mathematical theorem.
Now, there's a lot of talk about interacting with the physical world. And what is the next stage when security, safety, and technology are becoming ever more combined, become the focus of everybody?
If these systems can break, well, security is a really hard problem because to design a secure system, you need to prevent all possible attacks. But to break in, you just have to find the one attack, the one little place where people missed things. But
it's amazing that they could find it.
It's disturbing.
Okay.
Disturbing, but maybe not surprising, because most of these systems are built by humans, and humans make mistakes, just like these LLMs make mistakes. But I would say the way to use the systems is to try to have them find the bugs and then tell us how to correct the bugs. Let's use these systems in a positive way. I think the cat is kind of out of the bag. I think we do need some kind of government regulation, but I think laws are always way behind technology. But we should use the technology for good.
Any suggestions?
I would say in general, I would like to see more scientists play a role in government, because I think the scientific point of view is very important. And knowledge of technology is very important. And if you don't have government officials, at least some of them who can give expert advice on these fields. So I don't have a specific solution other than to try to say, let's bring the experts in and seek the best possible expert advice from a diversity of points of view.
Do experts want to really participate in this?
I'm sure some do and some don't. Personally, at this stage of my career, I'm happy still working on the amazing problems that I find. There are many more problems that we haven't solved than problems that we have solved.
It all started with curiosity. A single drop of an apple, a hidden pattern, a dream. AI is igniting massive changes in society. Science is reshaping human lives. This summer, join me to meet brilliant minds for raw dialogues, fun tours, and honest debates to probe the big questions shaping our future. Together, let's celebrate the season of AI and basic sciences. One of the problems is how to make sure the computation, as vast as we could have these days, still limited. So how to make it efficient in the most efficient way, how to restructuring the AI system so that things can be better done with the most efficient way.
We were starting to make progress on global warming and limiting power consumption and so on.
Yeah.
And now these companies are building these huge data centers contributing to global warming because they're not necessarily powered by wind or solar. It's all about computation for computation's sake. They're not spending enough time trying to make these systems efficient. And
Smart.
I am convinced that they spent more time trying to build in efficiency, put some algorithmic smarts into these systems, we would be way better off on many fronts.
What are some of the trends in the efficiency building do you see these days?
Well, you need to limit power consumption somehow. You need to redesign these circuits so they're not based on complete connection. You need sparse connectivity, which all by itself would seriously reduce power consumption, I think.
We see some large language models consuming extremely high computation. Others could do it in a so-called more efficient and smarter way with the limited sources they have.
I think there needs to be a lot of work on this efficiency question. I know China in particular, there are companies that have developed large language models that are almost comparable to the best coming from other places, from the US, and are much more efficient.
Yeah.
Obviously there is room, but I think people have not sought efficiency. They're just scaling up because they want to be first, but I'm not convinced that the first
is the key. It's not the key. Yeah.
I don't think so.
What is the key then?
Well, thinking about it some more, right? The second one, let's see how these systems work. Let's experiment with them. Let's improve them. Maybe we need to slow down a little bit, take our time, try to understand better.
Surge is not a strategy, according to you.
It is a strategy, but maybe not the best one, and maybe not the winning strategy at the end.
Meanwhile, we see discussions about open weight, open source, vis-a-vis closed source. We also see some kind of business competition among some of the LLMs have managed to let some of those earlier closed source become open source. How do you, Professor, observe the current trend, the latest events? You don't have to say which is better, but I'm really curious about how open source, closed source likely to serve their different distinctive roles both for businesses and for the public?
Well, I would say as a basic scientist, I believe in open scientific research, which means open source. We've seen in the software field, open source software has, I think, pretty much taken over, except for certain special areas. So it may be that open source LLMs will ultimately be the answer, but we'll have to wait and see.
Internet from the earlier time, extremely expensive, extremely rare to have access to now, of course, it's become a necessity infrastructure for everybody,
Yes.
almost free of charge. So are we going to see a similar cycle, do you think, Professor?
One could extrapolate to that truth. I think that's a reasonable hypothesis, which raises the question, how are these companies going to justify all the money they're spending on all this computing power, which again is another reason to look at efficiency. Maybe you get tremendous efficiency gains by changing the way these systems work. So maybe they save money and they have more chance to make significant money on their investments.
What is really, Professor, driving the latest development of artificial intelligence?
AI, as long as there has been this field, goes through these cycles. So we are now near at the top of some hype cycle, I think, with regard to large language models.
What about agentic?
Again, the issue is, how do you control these things? How do you make sure they're doing what you want them to do? I don't have the answers, but I think it's a very powerful technology. It's not going away, but we need to be careful in how we develop these systems.
What's going to be the nature of human being that would distinguish us from the best machines, do you think, Professor?
I see these systems as the latest technological tool to help human beings be more human and do more of what they're capable of. I tell my students, what does it mean to be a great scientist? It's not necessarily solving the problems, it's asking the right questions.
Right.
These systems are great at helping us solve problems. Let's ask the right questions. This gives us the freedom to ask more questions and maybe get the answers.
What does it take to ask the right question?
Well, you need some experience.
Yeah.
That's what learning is all about.
Right.
That's what learning is all about. I think an interesting challenge for educators, including people like me, is how do you get students to understand that you need to learn how to think, and if you use these AI systems to do your assignments, where does that leave you?
Right.
This is a hard challenge. I think the way we educate students is going to change in interesting ways. I've been on sabbatical for a year, but now I'm going back to teaching, so I get to confront this problem along with my colleagues. Do you prohibit the students from using these systems?
That's
you can't.
impossible.
That's unrealistic.
Yeah.
Yes. Do you redesign your assignments so that the systems don't help? I think we have to figure out a way to incorporate these systems into the educational experience. I think it's a huge challenge for educators.
Not only for the educators, but also for scientists yourselves. I mean, scientists need to present papers to show their ideas. Now they are all rushing to AI for help.
Yes.
It's much more efficient. If you don't use it, others going to use it anyway. So that's the logic, right? So what will be the eventual, value of human being in that regard? When you say experience, interesting, what is the experience?
Curation. I mean, there's going to be a lot of garbage that gets produced by these systems. Who's going to decide what's good and what's bad? We need human
judgment.
We need humans in the loop. Yes, judgment, exactly.
Responsibility too. Who will take the responsibility if something went wrong? That is another big question.
That is a very big question.
To scientists, what should be the answer?
I don't have an answer. I think in the software field, software designers and companies that sell software have gotten away with a lot for a very long time. And I think there is some responsibility on the part of software designers, which would include these companies that are producing the large language models. They have some responsibility for the results of their artifacts. Maybe that's a controversial point of view, and I don't know how you enforce this, but society is going to have to figure out the consequences. And it's going to be some collective responsibility. We need some rules. We need some ability to, I mean, it's not the model that's responsible for the mistakes. Who's responsible? The user, the designer of the system. It's a challenging question.
Yeah, we are already seeing so many examples of this. For example, miniseries that you use AI characters.
Yes.
And these AI characters might become, you know, the super advertisement stars. So are these AI characters going to be responsible for the products that they are selling, right? Who should be responsible for that? These are all entangled interest webs.
Yes.
But eventually, when this is becoming already part of life, we have to answer that question very efficiently.
Governments better get to work on this because it falls to governments and the legal system ultimately to figure out how to deal with these issues.
We see governments have been doing that. Tell me your thoughts
I suppose we're running an experiment, and the experiment is going to tell us the answers to these questions. People want to know the future, but it's impossible to know the future.
But then how to evaluate which one is better? What do you think are some of the factors that really would help us to evaluate which system or which approaches at this moment, experimenting, can be a better one?
Well, on the one hand, which approach is producing the most damage, and on the other hand, which approach is producing the most value to society. So we're getting benefits, and there are going to be harms, and we'll have to weigh the two somehow. I try to be thoughtful. I try to be slow. I think we can take our time and be slow, actually. Maybe we just need to slow down, think about these issues.
Yeah.
We don't need to be in such a hurry.
Is it possible when you see others are trying to hype the geopolitical challenge?
Yeah, it's not so easy. You have to believe that the tortoise wins the race, right? You got the rabbit and the tortoise.
I love that
who
analogy.
wins the race?